So you've met Clarence and you can now find an expansion for any function that you are given. There are some that are very common though, and these have already been done for you and are given in the formula book. So if we have a look on page 18 of your formula book, you can see that we have our original Maclaren's expansion, and then we've got the Maclaren's expansions already worked out for us for e to the x, log of 1 plus x, sine x, cos x, and arctan. Notice that they all have different validity ranges. And we're now going to use these in some standard functions in a similar way to the binomial expansion that you met in your A-level maths. Let's have a look at the questions on page 17. So the first one is asking us to write down the first 5 non-zero terms of the series expansion of log of 2 plus x. Now, you'll see that I've underlined the word series expansion. It's really important that you notice the difference. When we were doing Maclaren's, the question said using Maclaren's expansion. For these questions, it will say using series expansions. It is critical that you do the right thing, because if you do Maclaren's for a question that says series expansions, you will get 0 marks. And if you use series expansion when it asks for Maclaren's, you'll get 0 marks. Right, let's have a look at my solutions for these two questions. I've written them out. The method is very similar to the working that we did for binomial. So I'm working with the log of 2 plus x. I need it to be in the format that I have in my formula book. So I'm going to use the expansion here, log of 1 plus x. So I need a 1 at the beginning of the bracket. So I'm going to take my question and I'm going to factorise by taking a 2 out. So I get log of 2 and 1 plus x over 2. I then use laws of logs and split it into log 2 plus log of 1 plus x over 2. And now I can use the series expansion for the log of 1 plus x over 2. So I sub into the formula from the formula book. Wherever there's an x in the formula book, I replace with x over 2. I then simplify, which gives me this approximation here. And these are approximate because we have used a series expansion. And then I must also quote the validity range. So when I did my expansion, I used x over 2. So I put x over 2 into the validity range from the formula book that you can see here. And then I simplify, taking care with my minus signs and my inequality signs. In this case, it just divides or multiplies through directly. So that's question 1. Now let's have a look at question 2. We have a log question. I need to split it into 2 log expansions, which you can see that I have done here. And I've used my laws of logs so that I can get an expansion for this term and an expansion for this term. Using the formula book, you can see these here. That all simplifies down with a little bit of algebra to this result. And again, we have an expansion because I have used series expansions. The valid for is a little more complicated for this one because I have two expansions. So I have to consider both of them. I divide through by the 2. I divide through by -3, making sure that I have dealt with the inequality signs appropriately. The overall validity of the expansion is then the most restrictive of the two expansions, which in this case is this one here. So those are the introductory questions for series expansions. We've got one more to complete, which is number 3. And it's putting together two functions. And therefore, two series expansions. Now, we are asked to neglect terms above x to the 4. So that shortens the work considerably. I need the expansion sign of x. From the formula book, that's x minus x cubed over 3 factorial. And the next term will be x to the 5. Now, I may need x to the 5 when I put it into the compound function. I won't add it in at this stage. Let's think through when we do the next line of working whether we need it or not. So I'm being asked to find an overall approximation for e to the sine of x. So that's going to be e to the x minus x cubed, simplifying 3 factorial over, that becomes over 6. Now, let's work with the exponentials there. That's e to the x times e to the minus x cubed over 6. Expanding both of those using the expansions from the formula book. The first one I get 1 plus x squared over 2 plus x cubed over 6 plus x to the 4 over 24. My next bracket will give me 1 plus minus x cubed over 6 plus. Now, let's think about this. If I were to have another term, that would give me x cubed squared, which would be x to the 6, so I don't need that. If I'd had another expansion by using terms higher here, I would have been working with terms that were x to the 5. So the power would have been too high, so I didn't need any further terms here. X to the 5 is a term with n greater than 4, therefore not required. I can now simplify my two brackets here by expanding. So we've got 1 times this bracket, so that's 1 plus x squared over 2 plus x cubed over 6 plus x 4 over 24. I've then got x times, I've then got this term times the bracket, and the only term that I'm going to need from here is going to be minus x cubed over 6, the first one, and the second one minus x to the 4 over 6. And if we simplify that, we get a final answer of 1 plus x squared root 2 minus x to the 4 over 8, with some of the terms cancelling. So that's putting together two expansions to come up with what we'll call a compound function approximation.